So in this video, we are going to learn one new concept. It is basically the congruent transformation. Okay. So we have to reduce the following quadratic form, which is given over here, to canonical form. Okay. So what is the procedure using the congruent transformation? That is the question, right? So first we have to form a symmetric matrix A from this congruent from this quadratic form. We have to form the symmetric matrix A. How to form that matrix? Very simple. I'll tell you directly how to write that. So the basic idea here is that now here how many variables are involved, that you have to see first. X1 is sitting, X2 is there, X3 is there. That means you have to understand it will be 3 cross 3. Simple. So we have to make one 3 cross 3 matrix. Now after making this 3 cross 3 matrix, we have to write here X1 variable, X2, X3 above this matrix. Here also column wise you write X1, X2, X3. Simple. Okay. Now here you have to now observe this quadratic form which is given in the question. X1 square is given. Simple. Okay. So X1 is sitting here, X1 is sitting. So when I multiply both, I should have the element over here. So that will become X1 square. X1 into X1 is X1 square. That particular coefficient you just copy paste over here. So it will become 2 here. Simple. Next. X2 square, where it will come? Here X2 is sitting, here X2 is sitting. Multiply both right over here. I hope you are understanding. This is sitting in second row, second column. So which element? Here it should be the element sitting. So it is again 2. The coefficient you have to copy paste. Next, x3 square, again the same thing. The x3 square means it is again the diagonal element. So it will come over here. Done. Next. Now we are having what? One more element over here, right? X1, X3. Now you will be having one doubt that X1, X3 is here. You should write the element over here, or X1, X3 also is here. You should write the element over here. You have this doubt, right? So what you have to do? See, whenever the diagonal elements, you can directly copy paste. There is no doubt in that. Other elements, whatever is there, you have to take the half of coefficient of that. Half of coefficient of that. That means x1, x3 is there, x1, x2 is there, whatever is there, you have to take half of coefficient. So here it will become half of 2, which is 1. So one way should I write? Here or here? You have to write both the places. So it should be here also, here also. Now there is no doubt, right? So 1 will come. Why 1? Because I have to take half of this coefficient. Remember, here I didn't take half because I said directly the diagonal elements coefficient has to be copy pasted. Other elements, whatever is remaining, you have to take the half of that coefficient. Okay. So rest of elements, what you have to do? You have to just put 0, because that is not given in the question. So this matrix is done. Let me just name this matrix as what? A matrix. This is the symmetric matrix. You can understand from this. Symmetric in the sense what? A transpose, if you take, if you change the row into column, it will become the same matrix. Okay. If you take the transpose, it is same as the matrix itself. That is fine. Now let us proceed. This was the first step. Let us just remind you that this is the first step. What is the first step? Write the quadratic form into a symmetric matrix. Simple. Second step, in the congruent transformation we'll go. So second step is, whatever the A matrix is there that we found out, that should be equal to I into A matrix into I matrix. Okay. Now what is I matrix? I is the identity matrix. Here also I is the identity matrix of the same order A. Now this A should be kept as A itself. Remember, this particular A on the LHS side, that is nothing but the given in the question, that whatever we found now. So let me just write and show you. So the A matrix will be written like this. The same thing you copy paste. 2 0 1 0 2 0 1 0 2. Now put equal to, now identity matrix also will be what? 3 cross 3, since A matrix is also 3 cross 3. That will be 1 0 0 0 1 0 0 0 1. Done. Next, A matrix is sitting, as I said, keep this A as A itself. No need to disturb that. Next, one more identity matrix is there, that should be written as again 1 0 0 0 1 0 0 0 1. Done. So everything 3 cross 3 matrices are there. Now next very important step, now it starts. Okay, so we have to write in this form. Now important step is that you have to observe this A matrix. This particular A matrix, whatever is there below this diagonal element, you know, this particular thing 2 2 2 is sitting below that diagonal elements, whatever elements are there, that you have to make it as 0. I repeat, that diagonal elements you have to make it as 0 below the diagonal elements. Okay, not above, below. So this particular element we'll call it as pre-multiplied I. Let me just write it over here. So this is basically called as pre-multiplied I because it's multiplied before the A matrix. So this is pre-multiplied, and this particular matrix is post-multiplied after this, after A matrix, right? That's why it is post-multiplied. No need to remember this. I am just telling for a clarification. Always remember, pre-multiplied matrix will be performing only the row transformation. So when you apply the row transformation, we have to see only the pre-multiplied I. We should not disturb the post-multiplied I. And post-multiplied I will be focusing on column transformation. Okay, column transformation. Now, our intention is to make the diagonal below the diagonal elements as 0. So let us start. This particular element I have to make it as 0. So I am going to apply one row transformation, that is nothing but R3 becomes be 2 value, right? You can utilize this 2 value, can be written as minus half of R1 plus R3. Is this fine? Yes, totally fine. Because here what happens? Let me just show you what I am trying to do here. So when I apply this one, what happens? Minus half of R1. R1 is what? This particular 2. So 2 plus what is R3? 1. So 2 and 2 cancel. Minus 1 plus 1 is 0. So I am trying to make it as what? 0. So that's what I am doing over here. Okay. So this row transformation can be applied. Now as I said, when you apply this row transformation, it is applicable to this matrix. Here remember, this matrix, row, column, everything should be applied to this, and whatever the changes is happening, it is based on row or column. Row transformation only you have to change this matrix, not this matrix. Okay, so let me just write that. So when you are applying on R3, row 3, only row 3 will change, other will remain same as it is. So you have to write first row as it is. Okay, 0 2 0. Third row I'll change. Third row, what happens? 1 will change it to what? 0. Next 0 is sitting. So let me just do the calculation also. So I am doing for this calculation, minus half of R1. What is R1? 0, right? 0 plus what is R3? 0. So 0 into 0, anything 0, so it will become 0 itself. Okay, 0. Next, coming to 2. So what happens to 2? Minus half of R1. What is R1? 1 plus what is R3? 2. So this becomes minus 1 by 2 plus 2, right? So take the LCM. So what happens? It will become minus 1 plus 4 by 2, which is 3 by 2 it will become. It will become plus 3 by 2. So here it will become 3 by 2. Okay. So if you want, you can skip this calculation part in the video. Okay. I am doing all the parts so that you can understand in one video itself. Okay. Next thing. Now, as I said, that equal to, you are going to put this particular matrix is based on the row transformation. So I have to change this matrix. So row 1 and row 2 will remain same. 1 0 0 0 1 0. Now row 3 will change. Okay, let me do the calculation. First element in row 3 0. So 0 minus half into R1. What is R1? 1 plus R3, which is 0. So it will become minus 1 by 2. Correct? So I have to put it as minus 1 by 2. Next, coming to next part, we are having the next element as 0 again. So minus 1 by 2 into R1 value is 0 plus again 0. So this will become entire thing as what? 0. Next, coming to the last part of row 3 element, we are having here 1. So minus half into R1 value is 0 plus R3 value is 1. So it becomes what? 1 itself? Yes. So it will become 1. So this part is done. A you multiply. Then the next matrix I cannot change. Remember, it is based on column transformation. So I will keep as it is. Transformation. When you are applying the row transformation, you have to apply the same column transformation also. Remember in congruent transformation that when you applied some transformation, that is here row transformation I applied in order to make this element 0, that work is done. But apply the column transformation. So what happens? The same thing has to be copy pasted. Just change the, see R3 is sitting, so I have to take it as column 3. That is equal to that becomes minus half of R1 is sitting, it will become C1 plus R3 is sitting, it will become C3. Done. Okay. So this is nothing but the congruent transformation we are doing. Next. So what happens again? You have to apply the transformation. Now this particular fix, it will be fixed. Now this you have to change. Okay. So this we not bother. Now let us focus on this thing. Okay. Column transformation means third column only I have to apply. Third column. So 2 0 0 2 0 0 because first two columns will remain same, correct? Last column will change. So let me just start with the first element in last column, which is 1 minus half of, okay, what is C1? C1 is the first element, that is 2 plus C3. What is C3? The element itself 1. Okay, so these two cancel. What is you're getting? You're getting it as 0. So it will become 0 itself. Okay, next, coming to next thing, 0 is sitting. So minus half of 0 plus 0. Okay, so C1 and C3. So you are getting again 0. Coming to next part, we are having minus the third element, minus half of the C1 value. What is C1 here? 0. Don't get confused. This column 1, not row 1, column 1 plus C3. What is C3? 3 by 2. So this entire thing is 0. So what is left of 3 by 2 itself? So it becomes 3 by 2 itself. Okay. So this part is done. Equal to. Now here in this matrix, column 1 and 2 will remain same. 1 0 0 1 0 0. Only change is there in column 3. Okay. So that calculation I have to do. Okay. So I will directly do how to do, see carefully. So 0 is sitting. So minus half of C1. C1 is nothing but 1 plus C3 is 0. So it will become what? Minus 1 by 2. Correct. So I will write here minus 1 by 2. Next 0. Next element I will take 0. So 0 is sitting. So minus 1 by 2 into C1 value is what? 0 plus 0. So you are getting 0 as 0 as the answer. Okay. Next, the third element. So minus 1 by 2 into C1 value is 0 plus C3 which is 1. So you will be getting S as 1 as the answer. Okay. So this is also done. So we are finished with the column transformation also. So this is the step we have got. Now we are finished with the second step. Okay. Now from this, what we are going to obtain? Let us go for the step number 3. Okay. After doing the transformation, step number 3. Remember here, we will be obtaining after the step number 2, which will be of the form what? D is equal to P transpose into A into P. This you have studied in diagonalization. I hope you have studied. Okay. Where D is the diagonalized matrix. P is the model matrix. You might have studied. A, okay. A is the given in the question matrix. Okay. Whatever is there. So here, this will be in this form. So if we compare this particular form and this particular thing, it is exactly same. A is sitting in middle. Okay. P transpose is sitting over here. P matrix is sitting over here. So why I said P and P transpose? See, if P matrix is nothing but this matrix. If you take the transpose of this, if you change the row into column, you will be arriving at this matrix, which is the P transpose. and it is equal to what? D, the diagonal matrix. The diagonal matrix will be having the diagonal elements only, other elements will be 0. Simple logic, right? So here P, we can just write it as, it will be useful afterwards also. So let me just write P matrix as, so what is the P matrix? This matrix: 1 0 minus 1 by 2, 0 1 0 0 0 1. Okay, then what is the diagonal matrix? D, just write this part: 2 0 0 0 2 0 0 0 3 by 2. Now this diagonal matrix, we can write the diagonal elements. Okay, so the diagonal elements can be written as, diagonal elements will be the d1 d2 d3. Okay, and the canonical form, you can write it as canonical form, because we have to find canonical form itself, right? So canonical form of the given quadratic form can be written as, so what is diagonal d1 d2 d3? So let me just write diagonal, whatever the elements are there, d1 d2 d3, it will be 2 2 and 3 by 2. Okay, just copy pasting this part, diagonal elements. Now the canonical form becomes what? What is the form? Remember this: d1 into y1 square plus d2 into y2 square plus d3, so d3 into y3 square. Okay, this is the canonical form. So this particular thing I am going to write, so that becomes d1 here it is 2, so 2 into y1 square plus d2 is again 2 y2 square plus d3 is 3 by 2 into y3 square. Okay, done. So this is nothing but the canonical form of the given quadratic form. Quadratic form was given in the question, that particular this thing. Now this is just the canonical form. Now we have to give the congruent linear transformation also. Okay, so for that purpose, that's why I wrote P here. Okay, then what's the use of P? We are going to do that. So we can write the particular question in this form. This you name it as step number 4. X is equal to Py, right? P is there, Y is there, X is there. Now what is P and what is X and Y? Now X will be the column matrix x1, x2, x3, and Y will be the column matrix again, which will be involving y1, y2, y3, again the column matrix. Okay, so X is equal to Py, I can write. Now what is Y matrix? Just now I wrote y1, y2, y3. Now using this I can write what? This two can be multiplied. So this particular row can be multiplied with this column, which is equal to x1. So x1 is equal to the first row into this, that will become 1 into y1, so y1, 0 into y2, minus 1 by 2 into y3. Okay, done. Next, x2 is equal to, x2 is equal to what? Second row into this column, that becomes 0 into y1 plus 1 into y2 plus 0 into y3, that will leave. Next, x3 is equal to, becomes third row into this column, so 0 into y1 plus 0 into y2 plus y3, so I'll just write y3. Now this is nothing but the congruent linear transformation. So we have wrote x is equal to py, so that will give you the congruent linear transformation. In that, the elements can be associated with this point, that is x1, x2 and x3. This will relate both. The canonical form is written over here from the quadratic form, and the congruent linear transformation is written over here.